Siapa nak beritahu sikit? Siapa pernah dengar, siapa tak pernah dengar? Pernah dengar ke tak pernah dengar?
Tak, doktor.
Kat mana tu? Kat mana tu? Okay, I think that since you are not corporate and you also keep quiet, I just give you a brief on the curriculum, so it will take no longer for this online class. So I hope that you understand what I'm going to say on the MC model. So let me share this one. Okay, the MC model is on about okay, MC or more column failure criterion. So it's a part of stress strain pass yang mana in this kind of the Yeild criterion, you may see that the failure of the samples for these kinds of material behave in which way. Either you may have samples behave linearly or behave linear, elastic, perfectly plastic, or you may see that it may has a strain hardening or strain softening, or the material behave linear or non-linear characterizations. So as you remember in the chapter 1, I have shown to you a few kinds of the behavior or deformations of the material, especially in soil, for example. If you take it one sample of comparison between rubber or soil, you may see that the differences, for example, if you take rubber, so the deformations or the behavior of the rubber fail is not will be similar to the soil. But some assumption need to be made due to the analysis that we want to consider it as simple as ABC. So these are the things, assumptions and parameters only involved in the MC model. If you get involved other than models, for example, hyperbolic, Drucker-Prager, etc., you may see that quite challenges in determining the parameters of the material. If you again remember, the material properties or the material parameters are depending on how it is filled during the testing. For example, triaxial, and then other test is a odometer and also shear board test. So the deformations while you're taking the reading, it tells you the how it is deformed and what is the maximum of the failure stress. Other than that, it is important for you to understand the yield criterion. For this kind, the yield criterion of this material that behave or fail in the Moore column, it is presented in the spaces. For example, major principal stress sigma 1 and intermediate principal sigma 2 and minor principal sigma 3. So all the yield criterion from 1A, 1B, 2A, 2B, 3A and 3B can be calculated using the equations are given here. As what you see, some formulas that we can have easily from the experimental results. But somehow the parameters can be also obtained from the stress pass. As you can refresh on our last class before midterm break, or 2 weeks or 3 weeks before, is on about the stress pass, how we can have the stress line, the failure line, and how it is correlate between the shear strength parameters to the stress pass parameter AB. So it is easy just to get what is the value for effective minor stress and effective major stress. You substitute into this equation, you will see that how it is behaved. The failure criterion also tells you whether the material is behave linearly, linearly or linear elastic, perfectly plastic, or is it the material out of the boundary, within the boundary, or etc. Okay, look at one example or the conceptual how we going to get one equations or the relationship when you subjected to external load, for example normal load F, acting perpendicular to the plane, and then you have a shear stress that acting parallel to the plane. This is what we're going to have originally, and how it is turned to the stress. So the stress is actually is a force that acting to the perpendicular surface area. So F over A, you akan dapat normal stress. Same goes to the T. T is a shear force. And then you know what is the respective area that being subjected by this load T. Now you can have the shear stress. So the sigma n and the shear stress can be presented in the column equations as what you can have as before dalam topik soil mechanics ataupun dalam geotechnics. These are the things or the shear strength parameters that you can have from the Moore column failure criterion. So as you can see, when you plot the shear stress versus effective normal stress, this is parameter effective C and also effective V. The effective C is the intercept on the shear stress axis. So the similar thing when you present it in the what we call it between the shear force T and the normal force F. So yang ni yang kita nampak ataupun you can use the similarity in representing what is the column criterion, what is the Moore column, and then how it is deriving from the original situations or conditions. And this is similar if you take it as a one plane and having a respective angle. For this angle we can consider as a shear failure angle, and same goes here. There's a effective minor principal stress sigma 3, and also you can have the effective major principal stress that acting vertically on the plane. So the plane here subjected to all these external or confined stresses, and due to the loading, the sigma and the shear stress can derived from this perpendicular plane. So what is important are two parameters: the effective C and the effective friction angle. So I think that this is the common thing how you represent the Moore column failure criterion with respect to the failure angle due to the external stresses on acting on the plane, whether it is vertically or horizontally. And then when you plot in the graphical paper, for example, and you present it in a Moore column circle, these are the things that you may have or you may plot on the graph. Okay, again, as I told you earlier, the yield criterion easily can be calculated if you have the minor and major principal stress, sigma effective 1 and also the sigma effective 3. In order to what we want to say here, how it is shows the relations between the stress path of the MC criterion, having this T and also the S. The T is the diameter stress and the S is the mean stress. So you just remember back kalau kata kita talking about the stress path T and S, is a line that indicate to you how the stress may influence may what we call it, dia dah dipengaruhi oleh tegasan laluan dia ketika dia mengalami kegagalan. So you akan nampak the changes from the total stress to the effective stress, whether it is in undrained or drained conditions. So the behavior also can be related to the more column Yeild criterion. So you boleh nampak kalau kata untuk kita nak tahu the behavior of the material fail in the more column Yeild criterion dengan menggunakan stress path relations, these are the things that you make take it from the empirical equation as if half the vector stress must less or equal to the C effective cos phi effective minus half with the sigma effective plus sigma 1 sin phi. So kalau you nampak kat sini, one of it represent as a S and one of it represent as a T. So bila kita rearrange balik, these are the things, for example, that we can have. Other importance, when you have some kinds of the signage to indicate whether the sample is tension or compression in geotechnical engineering, we may consider that the negative it is where the compress of the sample have occurred. So in other way, it can tell you also that at the moment or at the value of the effective major principal stress is the largest compared to the intermediate principal stress sigma effective 2, and you can see that the minor effective principal stress sigma prime 3 is lesser than sigma 1 and also sigma 3. That's why if you how to understand the directions, how it is act, you can see that for example when you have the axial loading, somehow the axial load can be notified as a effective sigma vertical, yang mana daya tu, tegasan tu bertindak dalam arah menegak. However, in the different ways, if you can have the confining stress ataupun effective sigma 3, you may see that the stresses are acting in confined all directions or particularly at specific in the horizontal directions. Okay, same goes to here how it is relate to the stress path, yang mana you akan ada two parameters A dan juga B. From here, this is some kinds of the Yeild criterion, part of the Yeild criterion for MC, and how it is deriving to have the B dan juga to have a C. So this part is the tangent to the line. And then the PC is the here. Kalau kita tengok nilai PC ni adalah nilai for the initial stress that act to the failure criterion. And the important part as part of initially how it is deriving from the shear and normal stress relationship. So from the beginning, A is derived as a 2C effective cos effective phi over 1 minus effective phi. And then meanwhile, B is a 1 plus sin effective phi, 1 minus sin effective phi. This B is similar to the coefficient lateral earth pressure punya equations lah. Okay, yang ni dia just formula lah macam mana dia nak visualizekan kepada anda the failure criterion. Okay, yang ni pun I have explained how the Yeild criterion of the MC, but this is in the full more column criterion. Just now in the beginning adalah failure Yeild criterion. Okay, kalau you look at from the front view, this is exactly face of the more column Yeild criterion, yang mana is bounded by these red lines. So this more column Yeild criterion in the deviator plane lah. Kalau you plot in the different plane, dia akan bagi you different but the shape is that you akan ada hexagonal shape lah, 1, 2, 3, 4, 5 and 6. Okay. Okay, yang ni adalah important part. What is the MC? MC is also known linear elastic perfectly plastic model. Kenapa kita panggil linear elastic perfectly plastic model? Of course, it consists of the two zones, which are elastic zone and also plastic zone. What is the perfectly plastic? Perfectly plastic meaning that after it reached to the maximum shear stress, then the stresses remain constant until it fails. At the time you akan nampak the strain, walaupun stress kita constant, strain masih lagi meningkat. Kat situ dia akan memberi gambaran pada awak, once it touch to the maximum shear stress and there is no further changes may occur in terms of the stress punya increment, however the strain increase by the constant stress. So kalau kita present it in the graph, so this is what exactly you have as I explained just now. First, bila you apply loading, the stresses also increase as well as your shear stress. Shear strain. At one time, bila dia dah reach to the yield stress, you akan nampak ataupun kat sini kita panggil maximum stress, dia akan remain constant pada satu tahap. Kat sini adalah region yang kita panggil perfectly plastic. Yang di sini juga adalah zone plastic. Kemudian you akan nampaklah pada keadaan yang mana elastic strain ni total strain consists of the elastic strain plus dengan plastic strain. So what is the yield stress? Yield stress is a failure stress for perfectly plastic. So in order to indicate mana point berlakunya failure, so bila dia dah meet to the yield stress. Okay, yang ni pun I have explained just now, yang mana kalau you ada strain, dia akan ada also the strain increment. So the strains are divided into elastic strain and plastic strain. I think that strain ni you kena tahu the definitions untuk strain. Sebab you strain dia ada relations to the stress. Bila you kenakan stress, strain terhasil. Macam mana kita nak relate hubungan stress dan juga strain dengan satu constant coefficient, we call it as a Young modulus. So if you don't understand what is the strain, there will be a problem. Strain ni adalah deformation, the changes before and after to the original shape. That's how you can calculate the strain. That's why bila you kenakan stress, akan adanya strain. Logically lah kan, bila ada perubahan kepada tekanan beban yang you tindak pada sampel, perubahan pada sampel tu juga akan berlaku. As remember, bila you buat experimental, contohnya unconsolidated undrained, you kenakan sampel and then you apply axial loading. At one time, you akan nampak the sampel starting bulking, and if you continually let it for some times of reading until the reading constant, you akan nampak some sort of the crack crack can be seen on the surface of the sample. So kat situ pun indicates yang mana dia dah mengalami failure ataupun distress. So yang ni yang saya explain the relations or the basic concept of the Moore column. So it is having the Hooke's law, how it is related between elastic strain increments and also the stress increment. So the stress increment is the stress acting in S direction to the which plane yang dia berada. So kalau you nampak kat sini ada XY, YY, ZZ, XY, YZ ni merujuk kepada kat mana dia bertindak dengan satah mana dia bertindak. Kemudian when you talk about Young modulus, there's another parameter that can be also obtained from that is the Poisson ratio. Okay, selain daripada Young modulus, Poisson ratio, and then the strength parameters, another important parameter in the MC model is the dilatancy angle ataupun the flow rule. So the flow rule can be divided into two types lah. Kalau you nak tengok macam mana flow rule ni derive, it is between the plastic strain increment is equal to the magnitude of the plastic strain times dengan the directions of plastic strain to the that the delta G over delta sigma is the directions of the plastic strain. Or this can be seen from the angle of the dilatancy. So the angle of the dilatancy, it is relates to volumetric strain. Maknanya kita nak tengok perubahan dari segi isi padu bila you kenakan beban. So the changes in volumetric strain can be easily seen if you have some block, kemudian you kenakan daya, you akan nampak perubahan isi padu. Sama ada the changes in volumetric strain in laterally or vertically. longitudinal or laterally. Kemudian in part of explaining to you what is the yield function, the yield function can be in a few conditions. For example, if you have the yield function f less than 0, so it is purely elastic behavior. Yang mana dia tak reach to the plastic conditions. But then if you have the f equal to 0 and the yield failure criterion increment is less than 0, that is the unloading from a plastic state. So that is the condition for the elastic behavior. Tapi kalau keadaan di mana you have the yield function f is equal to 0 and the f increment is 0, that is the elastoplastic behavior. So when it says the elastoplastic behavior, in your mind you dah boleh imagine the stress path ataupun the stress strain of this material. It will be having elastic zone and then perfectly plastic at the constant stress and the increase of the strain. Yang mana strain tu nanti kita akan ada elastic strain dan juga plastic strain. Okay, yang ni explain to you the conditions of the yield function kalau f more than 0, f equal to 0 and then f less than 0. So this is within the boundary, so that is the plasticity. And kalau you ada f more than 0 is a non-acceptable sebab yang ni dia punya yield criterion, the phase ataupun the yield criterion of the MC in a hexagonal shape. Okay, as I explained just now, dalam elastic perfectly plastic, of course, consists of the two zones, elastic zone and plastic zones. Dalam elastic zone, you may have parameters E dan juga Poisson ratio. The Poisson ratio kat sini is the changes in the lateral strain to the longitudinal strain increment. So, kalau you ada Poisson, you ada Young modulus, you boleh dapatkan nilai Poisson ratio. Okay, ini alternatively lah macam mana kita nak relate. Selain daripada menggunakan E, kita juga boleh relate antara shear modulus G, kemudian kita boleh relate dengan bulk modulus K. So, apart of that, kita juga boleh gunakan Young modulus dalam odometer modulus. So, odometer modulus ni can be calculated from this formula lah. Kalau you tak ada ni formula ni ataupun you ada dua-dua nilai E, ada nilai Poisson ratio, and then dalam case study you perlu masukkan nilai odometer Young modulus. So, they can be calculated. So, there's some conditions yang you kena pilih betul-betul which are the input parameter need to be assigned in the software. Sebab apa-apa pun input yang you masukkan, dia boleh keluar result, dia boleh keluar output. How do you verify the result? Trueness, sama ada dia betul ataupun salah, itu yang penting ataupun the crucial part consideration as a geotechnical engineer. So you nak letak consideration macam mana output yang you dapat daripada plastis ni acceptable or non-acceptable. Kalau dia acceptable, why? Kalau dia non-acceptable, why? And how do you verify it? Macam mana kita nak verify? So kita kena buatlah comparison from other articles, kemudian kita compare dengan other software and you have to betul-betul understand. Okay, not to forget about the project in the subject dalam course ni, kita ada 24% out of 100% untuk course assessment yang mana you perlu submit project tu dalam minggu ke 14. Okay, tak silap saya minggu 14 you kena submit project. So from this week until to the next 3 weeks is a period untuk you identify ataupun lebih mengenali self-learning berkaitan dengan plastis, kemudian berkaitan dengan geotechnical modelling, apa case study yang you nak masukkan dalam plastis, you nak simulatekan dia apa, nak modelkan dia apa. So, you dah kena identify daripada sekarang projek-projek apa yang nak jadikan sebagai project submission sebelum habis semester pada minggu ke-14. Not to mention about please don't copycat from the manual plastis ataupun you copy daripada kawan punya project, because I can detect, saya boleh detect even from the atypical behavior is not good practice kan. Sebab just imagine lah kalau someday you going out for job kan, you dah bekerja, it is not got a good practice lah untuk you buat style macam tu kan. You tak prepare daripada awal, walhal saya dah bagi tahu daripada week 7 sehingga ke week 14 tu ikutkan ada 7 minggu lagi untuk you polish daripada nak fahamkan plexis, lepas tu nak hands on plexis, kemudian you nak produce your own report plexis, and to the last submission in the week 14 ada 7 minggu. So kalau you buat last minute preparation, saya boleh detect mana you ambil you screenshot ke, you snipping tool ke, gambar output daripada manual plexis, make it your own report. You just type saja. It's not true because whatever project case yang you masukkan dalam plexis, you kena cite reference dia kat mana. Kalau you ambil case study in Malaysia pun, they must be cited. Kalau kata you ambil case project daripada JKR ke, mana-mana konsultan kontraktor yang you dah pernah buat LI hari tu pun, you need to letak evidence dia. Kalau kata you copycat daripada kawan pun kita boleh detect. Because of what this is individual project, it's not a teamwork project. Dia bukan project berkumpulan. Kalau kata you nak deal dengan kawan you, contohnya kau buat simulations, aku write up and then kita just share. No, it's not right because I can detect also, I can see that how macam mana you buat modeling simulations for different cases but you have the same answer. Even the plexis itself pun, kalau you betul-betul understand, in the small effect you assign dalam plexis, there will be different answer at the output result itu. You main dekat mesh discretizations ke, you main dekat boundary condition ke, you main dekat loading ke, dia akan bagi jawapan yang berbeza. That's why kita assign as an individual project. So kita nak tengok the trueness of the submission project tu. You buat last minute ke, you tak buat last minute. It is 24% so kalau you tak prepare from now, so that will be affected to last carry out your markah lah and then your punya grade. So I just remind every one of you to be alert and be prepared for the next coming classes and also the project submissions. So, penting lah, that's why saya tanya awak apa dia more column. Sebab more column ni nanti mungkin adalah constitutive soil model yang you will be considered to be used in your numerical model and simulations. Okay, yang ni pun benda yang sama dalam plasticity parameters. It is related to the stress pass. There are two parameters involved from the stress line and the stress pass. Kalau you look at to the yield criterion sheet pun, dia akan shows to you what exactly how the C and V can be turned to this A and B. Okay, last kali dalam parameter untuk more column ni kita panggil sebagai dilatancy angle. So dilatancy angle ni you can check what is exactly dilatancy angle. Not to forget dalam dilatancy angle ni is explained to you the plastic potential. Macam mana nak tahu dilatancy angle plastic potential tu berlaku ke tidak? One of it is bila you ada associated flow rule yang mana dilatancy angle equal to the friction angle, that is the condition you have the associated flow rule. Kalau kata you have a difference dilatancy angle, kemudian you have different value to the friction angle, kita akan panggil non-associated flow rule. Maknanya apa yang berlaku antara frictions of the material dengan dilatation of the material, they will be differently behave in the plastic conditions. So if you see from now on this slide, this is what's real conditions behavior of the soil from the experimental in the in the black line dengan bila you nak modelkan as a more column model. Dalam this kind the more column Yeild criterion is presented by the blue line. So logically you will see that the MC model is over predicted because they just take it assumptions close to the real behavior. However, it is not presenting the real behavior of the material. Sebab kalau you tengok this kind actually the graph is non-linear. But then you want to use the more column or linearly elastic perfectly plastic, you akan nampak sebabkan yang tu kita andaikan yang ni adalah garis lurus, similarly ni pun garis lurus. pada tangent line garis lurus, horizontal line pun garis lurus. Tapi sebenarnya bukan yang tu yang berlaku. Kalau ikutkan you ada non-linear behavior of the material. So dia fail pun dalam keadaan non-linear at the constant stresses. At this point, bila you plot, that is the conditions, the dilatancy and the volumetric strain can occur. In the last conclusions, that what is actually trying to show you from the experimental result is all the 5 model parameters consists of Young modulus E, the Poisson ratio nu, cohesion C, the friction angle phi, and the last one is a dilatancy angle. So in the total, only 5 parameters input are needed to be used in the numerical model and simulation. So it means that it's easy to be used untuk beginner macam anda lah. Tapi kalau kata as you go through with your working experience, you may see that the assumption material behave as an inelastic, perfectly plastic is actually not applicable to represent the real soil behavior. So at that time, you need to propose or you need to use advanced constitutive soil model. The advanced constitutive soil model is required more input parameters as what you have now. Kalau you tengok sini dalam MC model ni, kita hanya perlukan 5 parameters je. Untuk dapatkan 5 parameters ni, you dah boleh buat try as a test, you plot dia punya graph, you dah boleh keluarkan dia punya nilai E, nilai Poisson ratio, nilai C dan phi, dan lastly dilatancy angle. Tapi ada setengah part tu material of the soil lah, contohnya kan, sebab dalam kategori of soil when you look at into two major groups, for example fine soil dan juga coarse soil, sama ada coarse tu granular ke, sand ke, cobbles ke, kemudian fine soil such as silt, clay, there will be differently behavior. So it's not easy assumptions that taken as a elastic, perfectly plastic. Somehow, contohnya bila you nak understand the behavior of the fine soil such as clay and silt, there some ada input needed untuk you faham macam mana dia fail. So during that time, the MC is not applicable to be used in the numerical model. So you need the advanced model untuk replace this point of the stress, apa parameter yang sesuai untuk present it, ataupun you analyze on the granular soil behavior. The granular soil behavior, kalau just put yourself when you walking through on the surface yang berbentuk berbutir-butir pasir tu, at one time you akan rasa skid, licin kan, dia macam tergelincir sikit kan, boleh nak jatuh. So the frictions between the contact surface between your shoe, for example, and then the granular or the coarse material, we're having some kinds of the frictions, the force. So bila you nak study dia punya force behavior, the tension force ataupun any forces exist, there's not easy to take it easily consideration, just replace it using the Moore column. But somehow during that time, mungkin Moore column is not applicable anymore. So you need to figure out mana lagi model yang sesuai, contohnya Drucker-Prager ataupun the combinations of the coarse and fine grains such as silty sand. So maybe other advanced model that can be adopted in the numerical modeling and simulations. Okay. The statement, the Moore column criterion is a good failure criterion for soil. So because of this one, it says that easy to be understood. And then the soil can only fail in shear, soil cannot fail in compression. So the friction angle of soil is material constant. Okay, now we go to the advantages. Kenapa some numerical study, numerical model like to play with the MC constitutive model. For example, here is a simple and clear model. First order approach of soil behavior in general. First order approach meaning that dia tak melibatkan quadratic function, dia tak melibatkan polynomial function, dia just a linear equation such as tau shear stress sama dengan C plus sigma n tangent phi. So you just substitute the shear stress at failure, kemudian you nak masukkan normal stress, you dah boleh dapat contohnya C dan juga V. Other way round, you masukkan nilai C, you masukkan nilai V, you dah boleh tahu what is the maximum shear stress, for example. That's why it says it's easy and suitable for many practical applications. Limited number and clear parameter. Ini yang dia kata parameter senang, tak payah nak gagal-gagal, tak ada parameter tambahan. 5 je dah cukup kan. Good representations of failure behavior drain, dilatancy can be included. However, there's disadvantages about the MC model. Contoh, it is only applicable for isotropy and homogeneous behavior, yang mana it's not true to the soil. Until the failure linear elastic behavior, maknanya sebelum dia reach to the yield stress, it is behaved linearly. No stress dependent stiffness, no distinction between primary loading and unloading or reloading. So kalau you nampak tadi graph tu dia hanya linear at the first beginning in elastic zone, kemudian also linear which constant stress when reach to the plastic zone, yang mana untuk you nak nampak conditions kalau you apply loading ke kan, sebab dalam kita buat testing triaxial kita boleh ada conditions yang you put more loading additionally, kemudian you unload atau you nak simulate the geotechnical application, for example wall, retaining wall, and then you are doing excavation. So kat situ dia tak boleh nak represent the real behavior of the applications, how it is failed. Contohnya you nak tengok wall deflections tu, adakah dia deflect in forward ataupun backward, ataupun dia deflect dengan berapa displacement ataupun berapa dia punya deformations, yang tu dia susah. And the dilatancy continues forever, no critical state, undrained behavior not always realistic, no time dependency free. Okay, this is comparison. Kenapa sometimes MC is not recommended? It's due to, if you look at here, kalau you nak simulate the behavior of soil, real soil actually kita ada 4 yang modulus because it is non-linear. Tapi bila you menggunakan MC model, you only have one constant E, which is not true to represent the real soil behavior. So in conclusion, that the model MC cannot provide good matches at all stages of excavation in soft clay. What are the implications? Is a over-predicted or overestimate at the early stage. So this is one application on the excavation. So you akan nampak the beginning, first excavation, second excavation, third to the last step of excavation. You will see actually the material will behave non-linearly. However, when you model as a more column, it is as a linear. So bila dia linear, yang mana it's not represent the real behavior, that will cause to you overestimations. So bila overestimation, what are the impact? Impact tu kepada the cost project. So sepatutnya project tu kita boleh save cost kan, untuk you nak determine the wall height. Kalau you analyze, simulate dengan real data, real input, so dia tak perlu over budget, dia tak perlu overestimate, dia tak perlu doing some more extra sources lah. So kita boleh model in the right way. Okay, selain daripada tu, ini adalah suggestion for E, undrained dan juga undrained CU. For example, if you have few cases from here, contohnya lavender stations, the ratio EU and CU is 500. So kalau you nak tahu EU tu berapa, you substitute dengan undrained cohesion, so you akan dapat nilai EU. Okay, not to forget for you is that, sebabkan minggu depan tu kita nak gunakan Flexis, ataupun you dah kena start online course registration Flexis. So you will be exposed to the few methods in Flexis. So for example, method A, method B, method C and D. So I leave it to you to understand what are differences between method A, B and C, and lastly D in Flexis, supaya you tak salah guna. Selain daripada tu, untuk you just refresh balik yang ni kalau kata kita nak simulate the behavior of the material for undrained, UU, kemudian consolidated drain, and then it shows to you what exactly the behavior of the soil for different stresses, and then kalau UU dia assume they will fail in the same line. Tapi kalau you ada consolidated drain, so actually there's a variance of the yield stress. Contohnya the green line will be lowest and then the red line will be highest. So bila you present it dalam criterion ataupun the relationship in order to have the elastic material parameter, untuk UU dia akan dapat constant E. Ini kalau you model menggunakan more column lah. Tapi kalau untuk CD punya conditions, this is represented to you, yang mana for the first one, E pertama, angle pertama, tangent pertama ni untuk mewakili green sample. Kemudian tangent kedua mewakili blue sample. And then tangent yang ketiga mewakili sample red ataupun nombor 3. Okay, yang ni macam kalau kita take it sample as elastic lah, they explain to you the behavior for that time. Dia akan ada shear stress and then dia ada shear strain, tapi dia tak ada volumetric strain. At somehow bila you ada normal stress produce, you akan ada volumetric strain. So dia berbeza lah. Satu yang terhasil disebabkan oleh shear stress, satu lagi yang terhasil disebabkan oleh normal stress. If you take it as a elastic model. Kalau kata in the UU contohnya undrained behavior of the clay. Undrained behavior of the clay, you will see that the maximum shear stress for all more column sample will be similar. That's why when you plot, this is a non-linear and they will be producing to you the same Young modulus like here. Dalam more column model, you akan nampak one constant E. So what are the thing yang mana dia nak tunjuk pada awak at this condition, dalam undrained condition, it is called as a stress independent. Sebabnya kalau you tengok sini kita ada shear stress, you also have the shear strain. Bila you model menggunakan elastic model dengan Poisson ratio 0.5, the same thing as well to the real soil behavior. So there is no more issues lah. And then bila you kenakan shear stress, you produce shear stress, no volumetric strain, same goes to the MC model. Kalau you kenakan normal stresses, also do not have any volumetric strain. Samalah juga dalam MC model. Tapi macam mana pula kalau kita nak model undrained behavior menggunakan effective strength parameters? This is actually what you may see also in the practice. As I told, ada perbezaan method A, method B dan juga method C. Kalau you nampak from the beginning just now yang mana you ada undrained condition, kemudian dia adalah more column and the strength and stiffness parameters are effective. So yang tu kita panggil sebagai method A. Kalau kata you ada sampel keadaan dalam taxi the setting as a undrained and then it is as a more column, but this time you will see that the strength parameters are undrained conditions ataupun in the total stress, and the stiffness parameters are effective parameters. So yang tu kita panggil sebagai method B. So you akan nampak perbezaan dia bila you nak assign parameters untuk strength tu. Kalau method A dia akan menggunakan effective parameter strength, kalau method B dia akan menggunakan total stress parameter. Yang lain berkaitan dengan stiffness dia masih lagi sama effective. So yang ni pun dia nak cerita the same explanations. At this point you boleh guna CU dan EU. Macam mana pula kalau you nak guna effective C dan effective V? This is the conditions how it is explained to you, the actually condition comparison between the real soil and the more column model. This is what it says as a overestimated. Sepatutnya stress pass tu dia dalam keadaan curve kan, dia meet to the final failure line KF. dengan nilai 2CU. However, bila more column, you akan nampak dia tak melengkung untuk meet to the final line. Dia keep up straight. Maknanya dia terus ke atas sampailah dia jumpa KF. So you can see that the value of 2CU at the maximum diabatic stress ni is larger compared to the real soil. So bila case ni berlaku, you kena design lebih lah. Extra thing that kena apply lah kan. So this condition will be over predicted nilai CU. So when you use the C effective dengan V effective, it is over predicted for the CU value. So yang ni yang measured, yang ni yang you dapat daripada experimental. So samalah juga kalau you ada pore pressure response The pore pressure response is the effect of pore water pressure for consolidated undrained. So the predicted pore pressure is much smaller than the measured, so which is not true untuk yang sebenarnya. So you can see that sebenarnya UF kita tu nilai dia larger, but then bila you analyze in the elastic soil or the more column, you will see that the final pore water pressure is short ataupun is less than the real soil. Okay, this is the method A. As what I said, you menggunakan effective strength parameter ataupun effective stress more column using the effective C, using the effective V in the undrained condition. So it overestimate the undrained shear strength and underestimate the excess pore pressure of a normal consolidated clay. So kalau you tengok dalam praxis the recommendation untuk you guna adalah method B lah, senang. Kalau daripada slide ni pun they will tell you that if you have, kalau betul you nak try lagi lah untuk self learning just to confirm lagi, nak make sure betul-betul method B yang selalu orang guna instead of method A kan. So you can see from the final output analysis lah. In other way lah, there's one case here. It is comparison using the method A dan juga yang measured ataupun observe on the site. Apa yang you akan nampak di sini, yang mana nilai what we call it here deflection is less, underestimate compared to the measured on site. So sepatutnya bila you look at to this one closely, the wall deflections is around 325 at the level 10. However, when you look at to the analysis from the computer, it only shows less than 200, which is incorrect. So that's why the method A give the wrong deflections. Does method A always overestimate CU4 and C? So yang ni pun you boleh nampak sebenarnya bila you menggunakan these kinds of the model it is underestimate at the low stress and overestimate at the higher stress. Ini untuk case NC clay lah. Okay, how about the method B? Method B is a things yang mana undrained conditions tapi you menggunakan total stress parameter for the strength. So kita menggunakan nilai CU dengan VU kosong. I hope that you can see the difference. Just now kita guna C dan V effective. Tapi sekarang ni kita menggunakan CU dan juga VU. Okay, dalam case ni they will see a differences for this kind. That's why it is good to use method B instead of method A in the praxis. So comparison in the measured dan juga predictions, they shows always they shows almost close result. Maknanya kat sini on the right side is the measured data, and then on the left side is the computed data. So the last wall deflections is around 300 something. Similarly, what you observe from the results. So yang ni pun result dapat dekat site lebih kurang sama nilai dia. So in summary, what you can have is that ini yang I told you to understand initially before you have the hands-on praxis antara method A, method B dan juga method C. Okay, method A is not recommended because dalam method A you akan nampak dia menggunakan effective stress parameter which produce wrong CU. Maknanya nilai CU tu tak tepat lah. So the best thing is using the method B. Method B ni yang mana in the untrained condition and so total stress parameter. So kat sini comparison for the stress type method A, B adalah effective tapi method C dia menggunakan total. Kalau untuk strength, yang ni yang kita boleh highlightkan lah the comparison close the here to here. Strength untuk method A dia menggunakan effective, method B dia menggunakan undrained. So modulus sama untuk method A, B dan juga C dia menggunakan undrained modulus. Poison ratio is the effective nu. Method B ni they can use 0.35 but this is depending on the soil type, sama ada sand or clay. And then you may have the initial Q naught or OK naught T. So this is similar for A and B, exceptional for method C. What is the OT? OT ni nanti saya check dalam manual lah. Okay, yang ni adalah it is only say that how it important to use the right method in order to have the correct CU and how it is shows from the first slide from the first note yang saya explain about the Yeild criterion, yield stress, yield function, so the final stress, kemudian and then how it is derived to the effective frictions angle. Okay, yang ni selain daripada nilai CU, nilai C efektif semua tu, ada lagi parameter soil yang penting untuk you highlight lah kat situ, iaitu the friction angle. The friction angle pun please use the appropriate nilai V. So jangan salah gunalah sebab dia akan bagi different answer juga. Okay, in summary, I think that that's important part about the more column, iaitu kalau you nampak throughout the notes highlighted about the 5 important parameters of the MC model. Maknanya in order to determine the input of the 5 parameters on model ni, you kena tahu dulu dia punya stress history dia, kemudian you kena tahu dia punya data obtained tu daripada what kind of the experimental triaxial ataupun the soil behave in which conditions, undrained ke UU ataupun CD, and then the effective stress, total stress, and the stress of the soil, for example normal consolidated clay, over consolidated clay. Itulah benda-benda yang you perlu ambil tahulah. Selain daripada tu, you kena tahu juga the geotechnical applications. You are focusing in which geotechnical application, sama ada foundation, slope stability, retaining wall ataupun embankment or excavations. So any questions? No? Okay, untuk minggu depan kita akan jumpa di makmal komputer 1.5. So bawalah apa yang perlu. Untuk permulaan ni saya rasa you pergi sana dulu, get familiar dulu dengan komputer dia, kemudian software tu dulu, kenal dia punya interface, input dia apa benda, geometri dia apa kan, macam mana kita nak modelkan dia. So pada masa yang sama minggu depan tu juga adalah is a durations untuk you complete the online course tu. Dan once you finish the online course, please submit the e-certificate to gain or to redeem 5% marks. Okay, ada lagi soalan tak? Okay, don't forget to answer the learning activities for this week. Learning activities minggu ni tak susah, senang je. Okay, if you do not have any questions, so I think that I leave it to you to have your personal investigations on the praxis dan juga yang berkaitan dengan dia, dah mula boleh carilah case study untuk you buat project. Kemudian I think that I need to share something lah. Okay, nanti saya inform lah pada awak link kat mana apa semua untuk you access dia punya online course tu. Okay, I'll see you next week dekat Makmal Komputer. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doktor.
Thank you, Doktor.
Waalaikumsalam.
Baru dengar suara. Takut minggu depan kita dengar suara, kita tengok juga.
Thank you, Doktor.
Welcome.
Thank you.
Okay.
Thank you, Doktor.
Welcome.